Okay, this bit of the course is quite small and relatively straightforward, and it is looking at the difference between AC and DC current, which is overlap with National 5, and then something called peak and root mean square voltage. So DC current, if you see this on an oscilloscope, which you will see on Mr. Mitchell's video, which if you've not watched that yet, watch that after you've watched this, and it appears as a straight line on your oscilloscope at whatever voltage that your battery is. DC current is produced by batteries. The electrons are flowing in the same direction around the circuit all the time. So your current is going in the same direction, and your voltage is either always positive or always negative, depending on what direction it's going in. AC current, or alternating current, is what we get from a power supply. Again, in Mr. Mitchell's video, he'll talk a little bit about how that is generated, but this is what we get from a normal power supply, because it's how electricity is generated in a power station. The electrons are constantly reversing their direction of flow. In mains electricity, they do it 50 times every second, so they're constantly going backwards and forwards. So that then produces what's called an alternating current, which is reversing, and it's at a frequency of 50 Hertz, going backwards and forwards 50 times every second. On an oscilloscope, that would then produce a graph that looks like that. Your voltage, basically a sinusoidal wave. Your voltage is constantly changing direction, going from a peak, which is your maximum positive voltage. You've got a negative, which is the maximum negative voltage, which is exactly the same, but just in the opposite direction, so you have a negative in front of it, and then your 0 points and 0 volts, in the middle. So if you look at this on an oscilloscope, what you'll find is that the peak voltage is higher than the quoted value of the AC voltage, which again you'll see on Mr. Mitchell's little video. So the quoted value that we say for our mains supply, so mains voltage supply in the UK, for example, is 230 volts. That's essentially what we get most of the time. It's kind of like an average, but some of the time it's much higher than that, but not for very long at any point in time. And then you've got the same and the opposite with the negative. So the majority of the time, the value of the voltage is 230 volts, but you've got this peak voltage that's a little bit higher. If you're measuring voltage with a voltmeter, you get your effective voltage, or your quoted, your kind of normal voltage, so your 230 volts. If you're looking at it with an oscilloscope, you get the peak voltage, which is 325 volts in this case. There's a relationship, unsurprisingly, because there is with everything in physics, there's a relationship between the two. There's between this quoted value, which we call the RMS voltage, the root mean square. The formula to link the two is that the root mean square voltage is 1 over root 2 of the peak voltage. We can then do exactly the same for current. So it's the same relationship for both. So the root mean square current, or what we get most of the time, is 1 over root 2 times the peak current. If you were asked to work that out the other way around, it would be Vpeak is 1 over root 2 times Vrms. If you are using an oscilloscope, then you would see something that looks like this on the screen, and what you would have to do to work out, you can use this to work out the peak voltage, which obviously you can then work out the root mean square voltage from, and you can also work out the frequency from this. So the frequency is 1 over the period. So for example, on this one, the oscilloscope is set with 0.02 seconds per centimetre as our time base, so that's our x-axis. If we look at that wave, if you count one full wavelength, it's taken up 4 boxes or 4 centimetres. The time base is 0.02 seconds per centimetre. Then that is going to give you 0.08 seconds for a complete wave. So the period is 0.08 seconds, 1 over the period, gives you a frequency of 12.5 Hertz. So we can use the oscilloscope to work out the peak voltage, and from that the root mean square voltage, and we can also use it to work out the frequency. This is normally what you're asked to do in a question. So there's a couple of examples here. So for example, the period of a sinusoidal wave is 0.005 seconds or 5 milliseconds, and the peak value of the current is 4 amps. So it says calculate the frequency and then calculate the root mean square value of the current. So the frequency, it's telling us what the period is, so it's just 1 over period to work out the frequency. So the frequency is 200 Hertz. And then for the root mean square, we're just using the formula, so it's current rather than voltage this time. So I RMS is 1 over root 2 times I peak. So 1 over root 2 times 4, which gives us 2.8 amps. The RMS value should always be less than the peak value. So if you are getting more, then you've done it the wrong way around, or you've done something wrong somewhere. So just done, got a couple of examples here. These are past paper questions, so just to give you an idea of the sort of thing that they can ask. So this one, we have got lots of waves there on the screen. The boxes that we can see, that's so that one box is from here to here. So one complete wave is taking up one whole box. Don't be fooled by the fact that it's cutting through here. So that's one whole box. Okay, so one wavelength is one box, and it's telling us that the time base is set at 2 milliseconds per division. So that means that the period of the wave is 2 milliseconds. If we do 1 over 2 milliseconds, that'll give us the frequency. The Y on the Y gain on the oscilloscope is set at 4 millivolts per division. So to work out the peak voltage, we're just counting how many boxes up we've got. So from the middle, it goes up 1, 2, 3. So 3 boxes, 4 millivolts per division. You can work out what the peak voltage is. I'm not going to tell you the answer. You can have a think about it yourself and check on the last slide. Second example. So the other thing that they can ask you to do is to calculate either the RMS or the Vpeak of either the current or the voltage. So again, we've got our sinusoidal wave. We're not worried about the frequency this time, so we don't need to know how many boxes this way. All we're worried about is how big it is. So it's 1, 2, 3 boxes high. Tells us that it's 1 volt per division. So from that, we can work out what the peak voltage is, stick it into the formula that we've already talked about. So VRMS is 1 over root 2 of the peak, and then that should hopefully give you an answer that is on that list, and hopefully the one that is correct. So that's pretty much all that they will ask you to do. So there's not a huge amount to this. It's page 3 in your notes, and also in the questions at the end, page 27 and 28, there's a few questions that you can do if you wish to as well.